is a continuation of the lecture we had at our previous meeting. And I thought I would just wrap up the conversation regarding causal inference and then go through an example so you can see in a very simple way what we're referring to when we discuss the causal nature of applied economic research. Now, again, there's flexibility in what your finished project actually is. And like I've said, it may be the case that some of you decide to pursue non-causal projects, more descriptive projects or forecasting projects or things of that particular nature. Which is completely fine. However, even if you're doing a descriptive study or if you're doing a forecasting study, it's really good to sort of start from the perspective of considering causal effects, and that process will benefit regardless of whether you end up doing descriptive or whether you end up doing something more correlational, like say forecasting. So, and we'll talk about that more as the semester wears on, to be sure. So last time, what we were mainly talking about was basically this idea that ultimately the main goal of regression analysis is we're interested in estimating the causes and the sizes of the effects that those causes create. So there's a real kind of cause and effect thing here at play, which is one of the reasons why I use this particular example when I'm first describing it. So in Schrodinger's cat, if you'll recall, the idea is that there's a cat, it's placed into a box that we can't see inside of. There's a vial of poison and a hammer such that if the hammer falls, it cracks open the vial of poison and the cat potentially dies. And the idea was basically that until we open up the box, we don't know what's happened to the cat. We can't make predictions about what happened to the cat until we open it up. So there's some relative uncertainty there. And the physicist Schrodinger, basically what he suggested is that if you think about this in the context of time space, as time sort of extending forward, in other words, there's a time where we don't know what happened to the cat, and then we go forward in time, we open the box up, now we know what happens to the cat. But before we open the box up, we have no sort of sense of whether the cat is alive or dead. And he famously sort of suggested that in a way, we have to think about the cat as being both alive and dead, right? That's sort of the basic idea here. Really what I think Schrodinger is also pointing out, perhaps not necessarily on purpose, is that there is no such thing also as a counterfactual in this situation. So when we open up the box, the observation, the data that we get from opening the box up is the observation of whether the cat is alive or dead, whether the hammer has fallen, and potentially whether the vial has broken. And we would use all of that information to then make a statement or a prediction about what happened. So if we open the box up and we see that the hammer's fallen, the vial is open, and the cat is dead, then we have reasonable confidence in saying that it was the action of the hammer which broke the vial, which released the poison that killed the cat. Now, the truth is that we don't actually know with certainty whether that's the case. It may be very, very high probability that that's the case, but not certainty, right? The probability is not 1 or 100%. And so in that sense, we discussed in class last time that the vial in a way mediates the behavior of the hammer towards the cat. So we can think about the hammer falling and then opening the vial and killing the cat as the hammer killing the cat. But the actual killing of the cat is mediated through the behavior, the observation of the vial itself. And the vial could not break, or the vial could break, right? That's kind of the thought experiment that we're generating here. And we can kind of assess if given what happens, what the likelihood ultimately that the cat dies or does not die. So if the vial doesn't break, we may attach a very low probability to the likelihood that the vial doesn't break, but the cat is still dead. And we probably assign a very high probability to the if the vial has broken and the cat is dead, that it was in fact the behavior of the hammer. So the main problem here is this issue with counterfactuals. In other words, when we open the box up, we only have the one experience to draw data from. We don't have multiple experiences with the same cat. And because we don't have multiple experiences with the same cat, we are actually unable to definitively say that the hammer killed the cat. Or that even the poison killed the cat, or the vial of poison breaking killed the cat. The hammer could fall and it could scare the cat, right? And the cat has a heart attack and dies anyway, right? Even if the vial doesn't happen. It could happen, right? It may be low probability, but it could happen. But the basic scenario here in terms of Schrodinger's cat is very simple. We have a really good idea what happens if the hammer doesn't fall and or the vial doesn't break, and that is the cat will not be dead, right? And we feel pretty good that that's likely the case. In most instances of observational data, it's not nearly as simple as this, right? The probabilities aren't necessarily as high. And when the probabilities aren't necessarily as high, it becomes even more difficult for us to have a good idea of what that counterfactual would look like, or our attempt to estimate that potential counterfactual. So now let's go back to this discussion that we've sort of started, and we're going to continue now, which is this notion that years of education and the effect that years of education has on wage is confounded by experience, someone's experience. Now, what you'll notice here in this particular DG is that experience isn't mediating years of education. So it's not like years of education causes experience and then experience in turn causes wage, right? We see that in this scenario here, where here the vial strictly mediates the behavior of the hammer. It confounds it, it's still confounding, but it's specifically mediating, right? It's getting in the middle of that potential relationship. Here, it's a little bit different, right? Years of education and experience are assumed to be independent in this particular DAG. And we're going to put aside the potential for that not to be true. And in a real, more robust statistical setting, we would care very much about whether years of education and experience are independent of each other. For now, and by the way that we've drawn this DAG, we can see that is the case. So years of education independently affect wage, and experience independently affects wage as well, as our DAG would suggest. So we say that experience confounds the relationship between years of education and wage. Specifically, if we have data on just years of education and wage, so we have individuals' years of education and we have their wage, which sounds like a cause and effect type situation. The problem is that we don't know necessarily if what determines that particular person's wage was solely about their education, right? And again, putting aside the fact that we kind of know from a practical perspective that there are a lot of potential factors that go into determining someone's wage, right? But here the specific question is does education affect wage? And again, we're going to test that hypothesis. And in testing that hypothesis of does education have an impact on wage, we have to consider all the potential confounders that exist. And the reason why is because if we just regress wage on education, then the resulting coefficient estimate, the estimated marginal effect of education on someone's wage is going to be biased. The reason why it's going to be biased is because the effect of experience, that is the effect of experience on someone's wage, is going to move completely into the error term. Right? So if we don't put experience into our regression equation, then the effect of experience on wage is going to move into the error term. And then when the regression goes to estimate the marginal effect of education on wage, the fact that the effect of experience has moved into the error term will cause the coefficient estimate on education's effect on wage to be biased. We're not going to necessarily say whether we think that bias is positive or whether that bias is negative. There are ways that we can figure this out, but we refer to this as omitted variable bias, which we've talked about in class. This is the main concern, or at least usually the top line concern whenever we start thinking about running regressions, and specifically, of course, when we're thinking about estimating causal effects. So why are adding variables to a model, or taking a univariate regression model where we just regress wage on education, and instead running a multivariate model where we regress wage on education and experience? Why does this reduce or rather, I should say, why does this improve our ability to estimate causal effects? Well, it goes back to this idea that we don't have counterfactuals and observational data. And when we run regressions, because we lack actual counterfactuals in our observational data, there is a sort of simulation of counterfactuals that occurs. You know, not a direct estimation of counterfactuals, but rather that when you run a regression, the regression math is carried out in such a way where when you add variables to the model, whatever variable you put into the model, that variable's effect on the left-hand side, okay, is netted out. So for example, if we run a regression where we put both education and experience into the model, the coefficient estimate on education is going to be unbiased by experience, because experience is now in the model, and that effect is no longer going to the error term. And so if experience does matter towards somebody's wage, then including that in a model where we're trying to estimate the causal effect of education on wage will in fact cause that model to perform better. Specifically, it will reduce the bias, or at least take away some of the bias that we currently have in our coefficient estimate. So you have probably heard people say controlling for variables, okay? And when we say controlling for variables, literally what we're doing, and you can see this in the modified DAG picture, is we're cutting off that particular variable's effect on wage. We're holding it constant. You've sometimes heard this referred to as ceteris paribus, right? All else equal. So in attempting to estimate the causal effect of education on wage, if experience matters, we need to hold that constant. If we don't hold that constant, then it prevents any semblance of a counterfactual simulation, right? And what I mean by this is, think about it this way. Okay, imagine you're a particular person and you've achieved or you've earned a particular amount of education, right? Now, imagine that you have a particular job with a particular wage, okay? Now, a counterfactual for you would be what would have happened had you achieved a different amount of schooling, right? If you had earned a different amount of education. We don't know this, we can't see this, it's your particular counterfactual. But one thing we can do is that if we eliminate the effect of other variables on wage, like for example, experience, what we are doing is we are netting out the effect of experience and leaving behind the estimated effect on education, right? So in other words, in simulating the basic thought process of a counterfactual, we need to be able to say why education matters. To what extent does education affect someone's wage? And in order to do that, we either need a counterfactual or we need to control for variables in such a way that simulates a counterfactual scenario. So when we control for variables in an econometric model, in a regression model, this is essentially what we're doing. We are replicating, or attempting to replicate rather, the same principles that we see in random controlled trials. Okay, now it's imperfect, right? Observational data is not a random controlled trial. and never will, and never is. However, if we can think about our regression strategy well enough, and if we can accommodate enough of the underlying statistical issues, what we do is we get closer to that so-called idealized experiment that Angrist and Pischke talk about in the reading that I assigned, right? The experimental ideal is a random controlled trial. With observational data, we don't have that. So what we have to do is we have to sort of replicate, in a way, a random controlled trial. So why does controlling for variables push us closer towards that sort of scenario? Well, the reason is because by controlling for something like experience in our underlying regression equation, what we are doing is we are reducing the non-randomness, in a sense, of someone's wage experience, right? We know, or we at least we're testing to see whether education matters, and we believe that experience also matters. Because we believe that experience also matters, this means that the outcomes of someone's wage are not independent of their experience, which means from the perspective of experience, the wage outcomes are non-random. And in fact, they're partly determined by experience. So by including experience into our regression model, what we are doing is we're controlling for that effect, and in a sense, introducing back into the estimation of the effect on education on wage, we're introducing back into that missing randomness that prevents us from sort of understanding that counterfactual. This is why knowledge of the data generating process is so crucial. Okay, no amount of fancy statistics can overcome a misunderstanding of how observations are produced. So if we're trying to understand the relationship between education and wage, we first need to sort of wrap our heads around what that sort of data generating process looks like, right? So we take ourselves through that process and we understand that someone's wage is not merely a function of their education. It's a function of several things: experience, tenure, tenure meaning the amount of time they've been at a particular company. These things would also likely affect someone's wage. And so the univariate regression, just regressing wage on education, suffers from omitted variable bias. And this means that we can't feel confident that the coefficient estimate that was produced there is a real coefficient estimate. The bias could be so bad that it actually presents us a negative effect when in fact it's a positive effect, and vice versa. Or the bias could simply be that it causes us to over or underestimate the underlying relationship. So bias can be something that is everything from a small marginal problem to an existential problem with respect to statistics. And so omitted variable bias becomes kind of the first line of attack for researchers in reducing the statistical problems that they're going to face, and also is the first step in the attack towards trying to uncover causal effects. So it's really kind of the framework that you want to start with. Whatever your potential paper topic is, you want to think about what your main right-hand side variable of interest is, right? In this scenario, we're thinking about education, what your left-hand side variable is. In this scenario, that's wage. And then ask yourself, what are the things that I think potentially confounds the relationship between education and wage? And there's all sorts of things that could potentially confound it. And these are things that have to be considered. Another form of omitted variable bias that we'll spend more time talking about in future classes is what we might refer to as model misspecification. So this is a little bit different in the sense that it's not simply solved by sticking new variables in to a regression model, but it might be solved by changing the form of the existing variables in our model as well. Specifically, if we believe there are non-linear relationships potentially, and I'll give you an example of one in just a moment. But overall, applied economics research is mostly about understanding the characteristics of your sample, right? So whatever the topic that you're choosing, whatever hypothesis it is that you're ultimately going to test. In testing that hypothesis, you're going to collect a sample of data which has been drawn from a population, and you need to know what's going on in that sample. You need to know what's going on in the underlying distributions of your data, because it can cause all sorts of potential statistical problems. We've spent a lot of time talking about omitted variable bias here, but there are other problems as well: heterogeneity, endogeneity, I already mentioned nonlinearities, so on and so forth. So a lot of what we will talk about in the coming weeks will be sort of diagnostic ways of thinking about regressions towards the goal of uncovering causal effects, or at the very least, uncovering correlations that we believe actually exist, right? So correlations that are getting close to the actual correlation, or causal effects that get close to the actual causal effects. And it's important, I think sometimes students, when we talk about causal inference, they look at it as being kind of this right or wrong thing, right? So if I'm going to estimate the effect of education on wage, there's only one model to do that. And if I don't find that perfect model, I'm going to be wrong, right? One of the things that you're going to learn is that oftentimes there are multiple ways to run the same regression, and sometimes the results are pretty similar or largely unchanged, and sometimes even relatively small tweaks to your model can cause fundamental changes to your estimations. And so it's important, again, that you sort of don't hide from the statistical problems that you face. And applied economics researchers, we sort of have to hit these things head on, because it is the main thing that our colleagues and our reviewers are concerned about in our papers, right? If your paper asserts that you're estimating the causal effect of something, then your statistics need to be carried out in a particular way, and need to be thought about in a particular